Good morning, student. In the last class, we have discussed about the simple harmonic motion, the general equation of motion for simple harmonic motion, and also the velocity and acceleration of simple harmonic motion. I have also discussed about the importance of the phase factor, and I have requested you to please go through the slide. But none of you have replied till now, and neither you have given any kind of attendance. So now from today onwards, I am going to submit all my videos in YouTube, and you have to watch the video and write your name on it so that I can give you as an attendance. This is a mandatory things to do because I have to report about the completion of the class to our principal. So you must have to do it. You have to watch the video and then write your name in the comment section so that I can give you your attendance. So please take care of this thing. Okay, so let's start with the second topic of simple harmonic oscillation. In this topic, I am going to discuss about the superposition of two simple harmonic motion. For example, suppose two oscillations are coming in the same direction. First, let's just consider in the same direction, and they are having the same frequency. Okay, and but their phase difference, their phase is different. So we have to see what is the resultant of these two oscillation. This is known basically the superposition of two simple harmonic wave. I mean the two harmonic oscillation, they just add up like a ordinary number. Okay, so we have to see how these things will give us what is the resultant of superposition due to two simple harmonic vibration. First we will consider in one dimension and having the same frequency. Okay, so first consider two simple harmonic oscillation. As I have already told you, the simple harmonic oscillation can be given by this following expression: x1 is equal a1 cos omega t plus phi 1. Okay, here a1 is the amplitude of the oscillation. A1 is amplitude and omega is frequency, and phi is the phase factor. Okay, and let's just consider another simple harmonic oscillation. X2 is equal to a2 cos omega t plus phi 2. Okay, and both the oscillations are moving in the x direction because I have given you the displacement in the x direction only. Okay, suppose this is a harmonic oscillation which is moving in x direction like this, and also this is x1, say, and say there is another, and say this is x2. Suppose this is x2. Okay, their frequency is same because omega is similar for both of the two cases, and we are going to find out if these two simple harmonic oscillations superimpose, we are going to find out what is the resultant amplitude and what will be the frequency of the resultant amplitude. Obviously you can guess that the frequency will be the same only, but the thing is that their phase will be different. If you add up these two, their phase will be different and their amplitude will be different. You can easily guess it because two things we are adding just two simple harmonic oscillation to find out what is the resultant oscillation. Okay, so for that, what I am going to do, I am going to use a vector notation. For example, you see x1 here is in the x direction, and if you can see this factor here, cos omega t plus phi 1, this is a phase factor. So this is a oscillating factor. It cannot have a direction. So if it is moving in x direction, then what I will do, I will give a1 a direction. So it's in the x direction. Similarly, a2 a direction, and it is in the x direction. And we have to identify a1 and a2 through the phase angle phi 1 and phi 2. Okay, here we have assumed that phi 2 is greater than phi 1. Let's make this assumption. Okay, so now I am going to express x1 and x2 with respect to a vector notation, and let's see how it turns out. Suppose this is our A1. A1. How much angle A1 is making with the x-axis? Phi 1. Okay, as I have already told you in the last presentation, this is phi 1. Okay, and how much angle A2 is making with x-axis? Suppose this is x. How much angle? Phi 2. So let's plot it like that. This is say phi 2. This is say phi 2. Okay, so in order to find the resultant of these two vector, so what we have to do, we have to complete this parallelogram. Let's compare it, let's imagine it as a side of two parallelogram. So we have to complete this parallelogram and we have to draw the diagonal. Okay, so let's do it. Okay, then complete this parallelogram. Okay, and we have to draw the diagonal from here to here. Okay, so this is our A2 and this is A1. Okay, so this angle from here to here, this angle is phi 2. From here to here, this angle is phi 2. Therefore, this angle will be, how much will be this angle? Phi 2 minus phi 1. This angle will be phi 2 minus phi 1. Okay, so now if we just plot it like that, and what we are going to do, we are going to plot a perpendicular on this, plot a perpendicular here. This is 90 degree. Okay, so this is A2, therefore this side and this side is parallel. You see, this side and this side is parallel, so therefore it has to be A2. Okay, and this is 90 degree, and if you imagine this triangle as say A, this is say B, this is C. Okay, so now if you look at the triangle A, B and C, from the triangle what you can find, this angle is 90 degree and this angle is, you see, this angle is phi 2 minus phi 1. Therefore this angle should be also equal to phi 2 minus phi 1. Phi 2 minus phi 1. Okay, from simple geometry we can say this angle and this angle is similar. Okay, and its value is phi 2 minus phi 1. And let's say phi 2 minus phi 1 is equal to delta. Let's imagine phi 2 minus phi 1 is equal to delta. Okay, now if we see the triangle, for the triangle A, B, C, what we can write, AC we can write how much AC will be equal to, this side is A2 and this angle is phi 2 minus phi 1, this angle is 90 degree. Therefore we can apply sine and cos theta. Sine theta is equal to P by H and cos theta is equal to B by H. So AC, what we can write, AC is equal to AB, AC is equal to AB sine phi 2 minus phi 1. Okay, and how much is AB? AB is nothing but A2. Therefore we can write AB is equal to A2 sine, the phi 2 minus phi 1 is equal to delta. Therefore AC is equal to A2 sine delta. Okay, then similarly we can write BC is equal to AB cos phi 2 minus phi 1. Therefore AB is equal to again A2 into cos delta. Therefore what we have find, AC is equal to A2 sine delta and BC is equal to A2 cos delta. Okay, now you see, now you look at the triangle OAC. I am referring to this triangle OAC, this triangle. This is also a right angle triangle because AC is perpendicular on this line. Okay, so from this triangle, this is the resultant. You see, this is a vector, and OB is equal to a1 vector, and this is a D, and OD is equal to a2 vector, and their resultant is this vector, OA vector. So OA vector is also the side of this triangle OA and C. Therefore, we can write from triangle OAC, we can write what? This is a right angle triangle. Therefore, OA square is equal to OC square plus AC square. Okay, that thing we can write. Now, OA square, OC square is equal to how much? OB plus BC, is not it? OC is equal to OB plus BC. OB plus BC whole square plus, we can write AC square. Okay, OA square is equal to OB plus BC whole square plus AC square. OC is equal to OB plus BC whole square plus AC square. Okay, up to this part, I think it's okay.